So you can probably tell I got pretty creative with the names here. Jim and Joe. Jim's leaving at 9 a.m. He's going 40 miles an hour, and Joe's going the opposite direction, going 50 miles an hour. So here's my line for Jim. Oh, if you have no idea where to start, at least start drawing a picture with the facts, with the word problem. Jim's going this way, 40 miles per hour. We got Joe going this way, 50 miles per hour. But we got to keep in mind, Jim had a head start. Okay, so the distance Jim has traveled, we can make an equation for that. It depends on how many hours we've said he's gone. Jim is going at 40 miles per hour. We use H for hours. And the distance Joe has traveled, it would be 50 miles per hour. But since Joe is delayed a little bit, he leaves at 9:30 instead of 9. That means he's lost half an hour here. So I'm going to take the I'm using H for hours. I'm going to take the hours he's traveled. I'm going to subtract it by 0.5. And again, let's talk about that again real quick because that's an important part here. Jim's equation, I keep messing up the names, but red and blue. The red equation is representing 40 miles times however many hours. That's the distance he's traveled. 2 hours, he's gone 80 miles. 4 hours, he's gone 160 miles. Same thing with Joe, except Joe, the hours is back half an hour. Right, because he left at 9:30. Jim left at 9 o'clock. So we have to take whatever hours that Jim has traveled and subtract it by half an hour to get him back to where he's supposed to be gone. So after half an hour from 9 o'clock, Joe's gone nowhere. 0.5 subtracted by 0.5 is 0, and 0 times 50 makes 0. But after an hour, 1 minus 0.5 gives us half an hour, and half an hour times 50, Joe's gone 25. Joe's gone 25 miles. So hopefully that makes sense, and I should use D. This is the distance Joe goes. Hopefully that makes sense now for how we cooked up those two equations. They both describe the same thing. They both describe the distance we've traveled since 9 o'clock. So distance Jim travels plus the distance Joe travels, that should equal 205 miles is what we said above. We want to know when they're 205 miles per hour. So we plug in what Jim's distance is and what Joe's distance is into these words here. Then we have a little equation to solve for H. When we solve for H, they'll tell us however many hours it takes to reach that distance of 205. Right? And again, we just wrote it out in words first. We knew that if we were to take the number of hours that we've traveled for Jim, for the distance Jim's traveled plus the distance Joe's traveled, those should be stacking up because they're going in opposite directions. You add those up, and their distance needs to be 205 miles apart. So we can solve. I'm going to use the distributive property here and multiply that 50 to everything on the inside of that parentheses. Is that 205? Is that what I said to begin with? And now combining like terms, we get 90H subtract 25 equals 205. Oops, this isn't going to be a whole number. I kind of messed this one up. I meant to come up with a problem that would come up with a whole hour. 90H equals 225. So we have to divide by 90. That'll tell us how many hours it takes. So the number of hours is 2.5. And remember, this equation was based on Jim taking off first. So we started at 9. It's going to take us 2.5 hours. So we're at 11:30. That's when they reach 205 miles apart.